Okay, here we are with another stream. Got some things to pick up on and continue today. Don't have my color commentator with me. What is going on with the mountains in the background here? 2404. Oh, that's the release now. I thought it was like the year 2404. That's not right. By the water, is that cool? Cluster, that's the one you see on most Ubuntu desktops. Everybody likes to take cool pictures. One stands out. One's sick. Is that what's going on? What's the safe landing? It's like a cheesy video game. Whatever, I don't care. Yeah, screw it. Okay, enough of that, because we're going to look at Vim for the most part. The music may be a little overwhelming. Is it a little too loud, maybe? I don't know. Whatever. We'll try this. New approach. Haven't done it before. And this is the benefit of streaming to like nobody to start with, is I can do a real stream and I can play it back later and see how it worked out. Because I don't have anyone to watch or be disappointed with this stuff yet. What am I doing? Be disappointed in my bet. Look at me. I can't type today. Already. Off to a horrible start. Open source here. What am I in? GDV call. All right. What I need to check today is I need some comparisons. What I had happening so far was I need to open a new window. Oh, that's a private. I don't want a private window. I want a normal window. There we go. And I want to go to my get thing over here. Okay. What I'm looking for is a comparison of how the master branch is doing deployment calls. I believe this is going to be in con and devman. There's going to be a clicked thing in here somewhere. Clicked. That's what I'm looking for. What I'm checking. So what happens right now? Back up. If I run run local is one word. Speaking of which, I need to open. Oop. Okay, so Hakuzaru. I'm on the parser branch here. And let's open up a boom. Okay, let's open those log files. If I run Gajudesk here, move this over, move you over. Okay. If I run Gajudesk and I want to, let's get a browser window, wherever my browser window is. There we go. Oh, actually, so if I open Gajumarket and I want to look at like this contract, I don't think these are going to open. These should crash. Yeah, these don't. They're not indexed yet. On the Explorer, but if I open this and I open the contract editing interface, if I want to open a deployed contract from the chain, I enter this, doink, I do that. Oh, actually, is there a copied editor? There is a copied editor. Okay, so if I want to deploy this as a new contract, and I click deploy, and I have that, and then WV, yep, okay. So blah, seller address, and then ID and price. Now if I click deploy, what happens here is like nothing, apparently, right? And what's actually going on is back in here, I get reason, invalid transaction, nothing to check. Okay, so TX data is reason, invalid TX. That's happening because my, as it says, invalid transaction. What that means is I'm actually getting to a node. I'm submitting this transaction to a node and it's coming back bad. So that sucks. What I want to check here is in the case where I'm deploying, click, edit, load, close source, deploy. Oh, there's a deploy button. So I'm going to check the deploy path and see what's going on. Because deploy in the old Gajudesk works, new one doesn't. Okay, so we're dealing with an external system too, so it's not like you can just write a local test and make this go. I need to let's see. So we're getting the source here. I'm going to deploy to. I'm going to try to retrace the steps and make sure that we're doing the same thing here that we're doing in the new code. So here, wait, I was just at it. Okay, so here's the new code. Call. So that's the initializer that builds all the stuff out. That's a parameter sizer. Okay, so what happens is command button clicked, and we go to engage, and engage does this stuff. Okay. So if we're in the init case, create build. Are we already? Yeah, okay, we're already getting the build before we've gotten to this part. So the dev man is asking deploy prompt call. Should it just be deploy? Probably should just call deploy. But I think deploy just takes the build. It does, yeah, it simplifies things a little. I don't want to remember that. All this stuff every time. So, okay, we call deploy. We've already compiled it. So deploy 2 starts with the dev man actually doing the build process. So we've got the compiled artifact. What's compile do? Just to check, what's compile do? Okay. It takes in okay. No color commentary tonight, it seems. No big deal. We will carry on. So compile the source. That's just a bunch of junk. So it's like text. Sophia options, whatever. Sophia. Okay, ACI JSON, sure. SO compiler from string source options of ACI, sure. And then the ACI is that. HACI. We've put the ACI, then we put the ACI into the build artifact. Cool. That's complete. And that's what we get back here. And then we're going to call gdcon build. Okay, so what that is a message that's going to get sent to the controller, and as soon as that's fired off, it's a cast. You see this right here? It is a cast, which means that the dev man guy, he doesn't have to care what happens next. His job's done. And here's your ball of poop. Do something with it, and he's going to try to deploy with it. Well, what happens from there is we call do deploy build, and what do deploy does is the call junk over here that was do prompt call, internally it just packs it up as a do prompt call. But the reason that I'm wrapping that up is there's only one meaningful argument to provide do deploy, which is build, because this other stuff, init and none, in other words, the function definition is known. There is no contract address because we're deploying the contract, so we don't have an address yet. So the contract ID is none, and we've got the build. That's all we have. I don't want the caller to have to remember init, none, right? We just know that deploy is always calling init. We know that, and we know that we know the definition of init, and the type spec for init is in the build artifact. That's all we need. So I don't want the caller to have to remember that because they'll screw it up. I say they. It will probably be me. I will forget that, and I'll make a stupid call and whatever. So wrapping that up so I don't have to remember this is great. So do prompt call. We know what the fundef is because we just had that. We know what the con ID is because we just saw that. Build state. Okay. Well, tasks press blah. So name is a contract ID blah. Do list key state of. Okay. Select. Okay. Right. Do list keys. What that does is it asks the GUI, the main GUI window, which keys do you have and which. Well, we get a list of the keys that the controller knows, and then we ask the. I'm sorry, we don't ask the GUI because every time you switch which key is selected in the GUI, it sends a message to the controller and says, number 1, 2, 3, 4, whatever is selected of your list of account keys. And then the controller goes, do I have a key number, whatever? And if it does, it says, oh, well, that one's selected, and it remembers it for you. So cool. So it's got the selected thing, and then key find name is a combination of the contract ID and the function definition. So in this case, it's a combination of none and init. And if that already exists somewhere, we're going to pop that one to the front. So GDV call to front. that calls the window that we found. It's the current activity, and it says pop up to the front because the user like forgot about you. Like maybe it's buried under other windows or whatever. So we're calling a thing that pops up to the front. If we don't find it, then we're going to create it. So if we do list key find blah, if it's not found, it returns false. So call preferences. Yeah, okay, yeah, that's the GDV call thing. We're going to whatever. It's like the dimensions of the screen that you may have liked before. In this case, I think it just returns an empty map. I don't think we have a GDV call remembered thing. It doesn't matter. Args is the call prefs. Okay, that, and then the fundef con ID build selected. Oh, which key selected, and then the key IDs, sure. And yeah, the build's in there. So we're going to start the link with these args, and that is, we'll go into call here. Init. What? I've got a keyboard offset over here. Like I have like this keyboard here. Yay. And then on my lap, I have this keyboard because that one doesn't quite reach for this funny angle. And it's still at a slightly funny angle, so I'm mistyping a lot. Bear with me as I get used to this. GDV call start link. Ergs. What was this about? Oh. Ooh. My color commentator is watching this stream, but he will not participate. He's stingy with his time. I'm just kidding. People got things going on. So start link calls, ultimately, it calls this with this tuple, and then that goes through the WX object start link machinery to make sure that, you know, all the context stuff is spun up the right way. And so this tuple here, which is this call prefs fundef con blah blah blah, that is unpacked right here. So we have the prefs fundef con ID build selected keys. Yeah, and that's that. So we got the PID. So we get the window reference back, and a window reference is like a WX thing, and Erlang being this like functional concurrent language, and WX being this like C++, object-oriented, but like the flavor of object-oriented that everybody's been like tricked into using, the one where it's like structs with arms and legs. That version of OOP is what C++ is kind of tacked onto C, and the paradigms are quite different. So we get a reference back that's a reference to the way WX thinks of things as a reference. And then inside of Erlang, we can get the PID reference, the process ID. That is the way that Erlang references processy things. And then we're going to monitor that. The cool thing about monitors in Erlang is that if I monitor a process like this and the process is dead, I'll just immediately get the the dead note, the death note from the process, and I'll just handle it in the next message queue. It'll like the next time that we evaluate our queue, we'll just see that, and it doesn't hurt anything, and the monitor's gone. Like it's all cleaned up, it's very tidy. Start, and then so spawn link is a little trickier because if the thing you're linked to crashes right away, your process crashes too because you're linked. Unless you're trapping exit, but then you're in this like funky space where things that should kill you can't unless you react to them. It's easier to just react to the monitor message for death instead of getting wrapped up in like linking things too tightly and then trap exit all the time. And 99% of the time, you should not ever have to use a process flag like trap exit. Trapping exit is not a uniformly bad habit, but it's not a great habit. Monitors are the more powerful version for this particular type case. Anyway, so the user interface is this like UI record that I've got. So it's got the name of the thing, so I can look it up. It's got the PID, so I can reference that. It's got the window reference that I can use if I need to for WX stuff. And then the monitor reference itself. So that's all packed up. That's one UI. And that goes into my GUI tasks list. So the state record now is tracking this particular thing. If it dies or crashes for whatever reason, we get a really nice note about it. Handle down. We'll get the monitor, the PID, info, blah, 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 tasks. We're going to try to find the monitor reference, and if we get the UI back, it means that thing died, and now we reset. We have tasks without that, so key take does that. If we get a down message from just somewhere, we shouldn't be monitoring anything but tasks, but if we do get a task that we're not monitoring, it's not in there, then we're going to log an unexpected info. Like, oh crap, something died. And that's how that works. Should probably change that to a tell. Because I would want that on my screen. Well, whatever. I'll leave it for now. Anyway. So, my original question that set me off on tracing this whole path is that where's the build come from? Well, the build comes from the caller. The caller called deploy this build, which means the caller already compiled this. And has added an is converted the ACI into an AACI, which is what we need. Which is what, this stuff's about here. Let's forget the function specs and whatever. Those are all keyed by function name above here. So then what happens later is we click the action button, which we know by this ID. So we're getting a message in from the WX event system, sends us a message, and Erlang receives it as this message. And we react to that by calling engage, which is actually just down here. Okay, and so we're engaging, and we have the state. We have the build in the state. So we're going to get the chain ID. We got that. Somewhat ironically from the controller, we could have. Okay, so at the moment of deployment, in the future, we might know the chain ID at that time, but at the moment, Gajudesk is only connecting to one network at a time. So the Gajumaru has like Groot, which is the Gajumaru root, and that's the one that is the proof of work chain that's allowed to like mint. It's in control of minting Gajus. We have that like Fibonacci curve decline on Gaju minting over time. Money supply is capped, it's finite, and that's guarded by proof of work because we couldn't find a better way to do it than proof of work. We tried really hard, but there isn't a better way, turns out. So we have strict proof of work on Groot, but then Groot can have associate chains that are associates of the Gaju, and they can trade and do stuff in Gajus, but they can't mint the Gaju. Only Groot can do that. So which chain are we connecting to? Are we connecting to an associate chain, or are we connecting to Groot directly? That's what we don't know until we ask the controller, who are we connected to? And the controller will ask the chain to be like, hey, who are you? In the future, Gajudesk will be crawling the tree, like each currency in Gajumaru defines like a tree structure. Groot's the it's the financial authority for the Gaju. And it can have associates, and they can have sub-associates and so on. If you have another currency defined within the Gajumaru system, it will have a different financial authority at the top of its tree, and those trees kind of like overlap and intersect, and the different chains can participate in multiple currencies, and currencies can travel across that financial authority graph, the pinnacle of which is like the hub. The financial authority is kind of the transit hub for each different currency. The transit authority for the Gaju is Groot. Anyway, which within that sort of lattice of potential associate chains, which one are we talking to at the moment? That's the question that this has to answer. And currently, Gajudesk, this program, does not automatically crawl them and keep in memory a map of that right now. In the future, it will. But right now, we don't know the chain ID until we ask the controller, what's the chain ID? So that's what's coming out here. So then we call engage 2. Now that we got the chain ID, these are like debug notes for myself. We already know this stuff works, so I'm going to take these out. So we know the chain ID. We go to parameters. We get the parameters for the call. That's all the stuff that's like the gas and the gas price and what the caller ID, like the the public key of whoever's doing the call. That's all call parameters. And the time to live, because we have a TTL on Gajumaru, because you can't actually store everything forever and ever. You have to have some time horizon. So we have a perpetual kind of garbage collection thing in Gajumaru. You have to pay for how long you want a chain object to live on a garbage collected nodes. So that's that. This music's kind of dark, huh? I'm a bright guy. Not smart. I'm an upbeat guy. Chain ID, yep. Okay, then we get the parameters we call. So we're building up our state as we go. That's how these work. Did this work? Yes or no? If it didn't, handle troubling state error means essentially show like a modal pop-up. This didn't work and this is why. And it'll show the user that. So we're just stepping through this. Like, did that work? No. Did that work? No. Did that work? Args. So the call args. So there's the parameters of the call, and that's the ID of the caller, the gas price, time to live, that stuff. The arguments that are going into the call. So we're calling a function on a contract, on a smart contract, in this case init, and it's going to accept some arguments. So that's separate from parameters. So the parameters of the call, it's kind of the context in which you're making the call, and then the arguments that you're making that specific function call with is the distinction between parameters and args. So we have the parameters and then we have the arguments. We have 3 different representations of arguments because serialization is, a wonderful game to play. So Sophia args tells the serializer, the call data serializer has to know what form of argument am I getting? Am I getting Erlang terms? Am I getting fate terms? Or am I getting Sophia literals? The way you would see it in a Sophia contract. And in this case, we're getting Sophia literals. And it knows, based on that, it knows how to coerce them, because it's got the type spec of the function, so it knows which types are supposed to be coming in. And if it knows the notation, then it can know, oh, these are going to be strings, and I'm going to coerce them from string representation to whatever, based on whatever the type is, whatever the type spec is. So that's how that works. Then we get to engage 4, which, okay, here's where we split. If the function definition is init, then we must be deploying. So we've got that. We could match also on con ID being none, but like init's good enough. Okay, so we've got all that stuff built up. We know what the args are, which I don't really need this either. Did I even? Yeah, it doesn't really matter that much. Boink. If we get a problem with the parameters, we're going to get an error back because we're about to call Hakuzaru, which is over here. Was it contract? Create built. There we go. We're calling actually the next one down. This guy. We're calling contract create built with all that crap. Which you kind of have to. Like, if you look up here, all this is doing is like, putting in default arguments for you. It's not the best. You really kind of want to call the 8 arity one, which is a big it's a big arity. If I wanted to reduce the arity, I would just be wrapping up the parameters and the arguments in their own separate place, but it's like creator ID nonce amount GTL gas. Yeah, I mean, there's no way to get around that. Speaking of, When am I getting the nonce? Am I pulling a nonce? I am. Okay, so I'm calling next nonce PK. Next nonce public key. Okay. So the nonce is coming out of the params thing, blah. So this is encode call data. Actually, we can see encode call data here. We're doing the AACI work all over again here, which is kind of corny. That should probably be encode call data. I don't think encode call data is exposed by itself. If we see the way that these are defined, oh, ACI, right. We can include an ACI that's a label, and what that lets you do is you can cache an ACI. So if you've compiled a contract before, you're going to call it a lot, you can cache this. Ooh. I'm getting a message about an error that somebody's having. That sorted out in a little bit. Is encode call data public? I don't know that it is. I don't think it is. Okay. I kind of feel like I want an So contract call. You have to include the AACI as one of the call arguments. That's what you'd always have that. Create built, it's like this has the built thing and it's adding the AACI to it, but we're using the AACI in the preparatory functions because the AACI is kind of a mess to deal with. I like Jarvis's AACI better. Which means the compilers, actually, Peter mentioned this yesterday, that the compiler should do this for us, but we need to update the compiler to do that. Right now, Hakuza is doing this on its own. Yeah, but in call, I think it's in contract call. Yes, the AACI is one of the arguments to the normal like baseline contract call for Hakuza. Blah. Okay. Anyway. This contract create built, yeah, this one. Encode call data after you've got a whole encode call data. You have an ACI or you've got a reference to an AACI. Doesn't matter which one you have. It can look at, you can cache the ACI, so you don't have to recompile everything every time you call something because that's stupid. And then encode call data, it can receive Sophia arguments, or it can receive Erlang arguments, or it can receive Fate arguments. It's probably, yeah, it doesn't matter. Or it can receive args as just a list. I should probably put a tag on there like when is list. I'll do that later. It just wraps this up. See, it just, if we get naked args that aren't tagged, it wraps them up and calls itself again. Or, sorry, not right here. Encode call data too. It just calls itself again. So we just start back up here. And we have slightly different ways of doing this. We have a convert thing. We have an ACI, args to fate. We have a convert function that converts ACR just a fake, you know, whatever. So that's the call path we're on. So that's create built. We get a create transaction back from that. And then we call deploy. Now deploy is an interesting little creature. We go to the controller and we go to sign call. We're going to look for sign call, so we go do sign call, chain ID pub key TX, chain ID pub key. So the caller ID is the pub key in this case, right? Sign call. That's going to change as we add these, like, we're implementing in the chain all these like post-quantum cryptography schemes. We're also adding a variety of different like options for calling things, and the IDs become under those in those schemes. You wind up getting the ID, the public ID being a hash of whatever the key was, because the keys are like huge. You're not gonna copy paste somebody's like public key for like lattice crypto. Like MLDSA is not gonna have. You're not gonna write the public key out. It's crazy. Or big RSA. You like 16K RSA. You're not gonna type that stuff out. So 32-byte hashes of those keys is the public ID. So this is going to change a little bit based on that later. We're going to have like the full ID. Anyway, so deploy. I'm looking at this to do, put some basic checking in here, like blank strings at least. Sure, it should be possible to perform type parse checks over this since we have access to the ACI, but I'm typing, yeah. Okay, so basically if I pull the args out and then I check them against the ACI, I'm surely we have the functions for that inside Hakuzaru somewhere. I just haven't looked at it. But like if we can type check an argument and say coerce this from Sophia into the typed argument, and if that argument's wrong, in this list we would, like, instead of text control get value, if that was text control get value wrapped up with this is the argument thing, here's a list it's zipped with, go check that, try to convert it now ahead of time, and give me the fate converted argument. And if it fails to convert, then I know which argument it is, and then in the user interface I could say, hey, this one's the wrong type, and I could put like a message like, hey, this is the wrong type, and help the user. Okay. Okay, WordPress apparently has image processing limits or whatever. I'll figure that out in a second. Our marketing person's having trouble. So we is okay. Going to shrunk this down a little. Edit. All right. So deploy. We're calling sign call. Sign call is opening the keys. It's got the thing. It does HZ sign transaction. Ooh. I bet there's something missing here. Surely there's something here. Some TX. Oh wait, network ID. Oh, there's two. All right, there's two versions of this. There's a convenience one. Okay. Image beneficiation. This should minify really, really well. Sorry, slight digression here. I have to gonna index this image for web trash. A little bit too much of an index. Index it to 16 colors, maybe? Pretty good. Okay, and I'm going to export it as a PNG. And I want that interlaced because the proxy server is not super duper fast. Okay. There we go. So, signed transaction, unsigned binary, blah, blah, blah. There was a, what am I doing? I'm going to click this. There we go. Signed transaction. There was a signature thing in here. I think it was in the spend. Oh, it's Anka's out of spend thing. Okay, that's why. Right. So we do same transaction, same transaction. Transactions are this binary thing. Transaction, secure key, chain ID. Yeah. chain ID, network ID, those are the same thing. You see like binary network ID up here, and you see chain ID down here. That's the same thing. I need to pick a specific verbiage. I just haven't. So sign transaction, we get sign transaction back. What happens up here? We get the payload, sign transaction, response keys to Postgres response is okay. Yeah. These operators drive me slightly nuts. Like, map syntax is not my favorite. I love how these don't mean anything on their own. You just have to know what they are. You know, I'm updating a thing. I'm matching a thing. I'm inserting a thing. All right. So we get the signed transaction back. Right? Yay, it looks like the problem in the other world is fixed now. Sign transaction, we have the sign TX, and then I think we just submit it like that. Except that post TX doesn't like it. So let's compare to the version of this that we know did work, which is somewhere. Okay, here we go. In this case, we compiled. This got the build. Okay, so the compile function put the ACI in there for us. We saw that before. We got the ACI out of it. Say we're deploying the contract. It's got the contract and cool, and then init spec. We're going to get init from the functions. We're going to deploy 3 from the state, init spec, and the build. Get a list of keys. Oh, right. So list keys. That's the same function we used earlier. It's got the one that's the index of the one selected. List of keys. We're going to go into deploy 4 with that. We have the init spec. Getting the first init args like definition for contract vertical. So this is all just setting up the same stuff. Okay, the call parameter. Yeah. Okay, some of this is moved around a little bit in the new call interface, but it's basically the same stuff. This is all, you know, that junk. So, okay, here's the interesting part. We'd show modal, and we're going to get an OK or a cancel back. If we get the cancel back, we're going to outcome is canceled, and we're going to deal with that. A quirk to using modals and WX is that, well, using not WX, but using WX Erlang, is that when you call a modal dialog, it freezes the parent screen, puts a little pop-up, and then you have like an OK or cancel button. If you click OK, you proceed with processing, and then you should give a definite result back to the call inside of a case like this. And then the next thing you do, regardless which outcome you got, is you need to destroy the dialog, because C++ doesn't do garbage collection for you the way that Erlang does. And like when in Erlang, if a process dies, all the stuff that process owned gets like reaped, and it's cleaned up and it's done. File handlers, sockets, whatever, they all go away. It's clean and nice and great. You don't have to think about it. In C++, you do have to think about it, and there's no obvious hint to know what C++ resource you had that you don't want anymore. So you got to tell it. And so you get your response back. You put that in a variable like outcome or variable label. These don't really vary much because we have single assignment. But anyway, you put your outcome thing into, call it something. and then destroy the dialogue, so it's cleaned up. You don't have that lingering anymore. And then deal with whatever the outcome was. So case outcome of okay param args do deploy, proceed through deploy 5. If it was a cancel, well, cancel. If it was an error, which is anything else, those are two cases that could happen. You'd have an okay with like some stuff. You could have a cancel, which is like they don't want to do this, so you just report the state back because nothing happened, or an error. Anything else is an error. So wrap the whole thing up, no matter what it looks like. Wrap it up and report that as an error. So handle troubling state error. That'll pop up a different modal that'll say this junk happened. Go figure it out, human. I wish AI worked that way instead of being like, oh, that didn't work. We should delete this repository. We should delete your production database. But whatever. We live in interesting times. It's like the Chinese curse come true. Deploy 5 calls. Okay, so we've got the state, we've got the build done, we've got the parameters and the args, and then we call deploy. Okay, and the parameters had the key ID. What I was looking for just now was like, where's the key? We had the key in the parameters, which is why we got the up here, the selected list. So we already have the key ID. It's been pulled out of the key list. It's packed into the args or the parameters somewhere. Deploy. Yes, here we go. PK. It's in the deploy parameters, so we know what we're doing. So deploy 5. gdcon deploy. That is. I'm gonna have to. Where are we at? Deploy. Deploy. Whoa, what's happening? Deploy build params and args. Okay. Not a hard wrapper to figure out. Do deploy. We like you. All right, so do deploy. What's different here? We have do deploy has the call parameters, got the init args, got the build, got the wallet, got the keys, chain ID, cool. We're gonna find pull the key from the list of keys, get the signature key out, get the signature key out. Yeah, got the signature key out. Oh, whoop, that's not the right thing. This is what I'm looking at. HC contract create built. Yeah. Do deploy 2 returns a create TX. Okay. Alright, so contract create built, create TX. Continue on with the secret key, the create transaction, and the chain ID, which I think is the same as what we wound up over here. Chain ID, public ID, and transaction. Okay. HC sign TX, create transaction, set key, chain ID, sign TX. Contract create built. Non-CTL gas price. Build. Create TX. Params, args. Contract create built, create TX, deploy. And then deploy does exactly these things. G-sign call. Is it possible I've got the argument order wrong or something? Chain ID, caller ID. Well, okay. To know that, let's follow back where we came from. Split this open here. So deploy is this guy. Let's see where we call him from. State, chain ID, caller ID, grade TX. Grade TX, yeah, it's all the same. No. Clear ID. No, it's not. Yeah. Okay. Okay, yeah. Okay. Retrograde built. Caller ID, caller ID. Knox. Oh. Look at that. This is why the argument ordering kind of sucks. This is another issue that I want to rectify, which is the contract create. So there's contract call and there's contract create. They all have the same arguments, or the same parameters, which is the caller ID or the public key, the nonce, the amount that might be going into it, the time to live, like how many heights needs to be alive, the gas and the gas price, right? The ordering of those arguments between the two calls, they have the same parameters, but the parameter order is like different, for just because it's stupid, and like I didn't notice that when I wrote all it's my fault. I just didn't notice that when I wrote this. So, and then look at me, I just did my own thing wrong. Let's see, actually this is gonna be the same deal down here. Oh no, it's not. I bet that's how this happened. I probably like copied that up assuming it'd be the same, and it's not. So I probably just like illustrated to you just now why that happened and why it's dumb. So I want those to be just, look at this. We've got the args. We have the name of the function we're calling. Okay, it's a little bit different because the create built, it like knows what, there's only one function you could be calling when you're creating or cloning. So it's barely different, but you basically have the arguments. You have, instead of the build, you have the contract name, the contract ID, and the name of the function you're calling. That's what these two are. And you got the AACI. So the AACI, the contract ID, and the name of the function you're calling. Those three things basically replace the build. Then you have, look, TTL, gas price, amount, nonce, caller ID. See, that's silly, right? Oh, also this is called GP here, not gas price, but whatever, same thing. Now, get that changed. What happens? Let's call this guy. We're going to open our contracts editor thingy. Where was my Gajumaru? Okay, I'm going to open this contract, pull it off its contents off of the chain. We're going to open it from hash doink. All right. Deploy. We're going to get... I bonked somehow just now. I'm not sure how I bonked, but I bonked. What did I do that time? Let's tail 430 03. What died? Bad match. GD Kwan died. Okay. GD Kwan line 473. I'm gonna move this over just a little. Okay. What I'm looking at down here is handle cast 2, line 473. Bad match. Okay, what would be not matching there? Handle cast do deployed. Does do deployed return anything different? Do prompt call. Oh, it returns a state thing, yeah. Oh? Do prompt call. Oh! I changed the do deploy thing, and that can update the state depending on what happens. That's what. So I did change one. I was like, "What the hell could crash?" I forgot. I remember I was doing the do prompt call thing, and then I'm like, "Wait, it's simpler if I do the do deploy." I switched to do deploy. Forgot that can have a state impact, and had it just matching on OK. And guess what? The state record does not match OK. State record matches the state record. So, duh. Okay, now we're going to open this from there. Boink. Haha. All right, so now we're going to click do deploy. It's going to crash again. I didn't see the pop-up yet. It's going to die. Maybe. Unless I have... Oh. That was quite the delay, wasn't it? Let's try that again. That was weird. No. Okay. Let's close this. What would have caused that delay? That was really interesting. Well, it could have been a network delay. Could have had a network. Probably was a network hiccup. QPQ address. Copy that. Boom. Boom. Portion. Yeah, so I do that. Okay, IDs and one puck. It's a one puck item. TX amount, don't need that. Okay, deploy. Let's see what happens. Invalid TX. We got it again. Okay, so why is that an invalid transaction? The only thing we know about the invalid transaction. Let's try a dry run on it. So we have, not that. I want to open deployed contracts. We're going to load from chain. Oh. That's somebody's address. It's not a contract address. Load from chain. Oh, that's right. I have some weird hang up on that. I put a note for myself yesterday about it. I need to figure out what's wrong with... So I'm getting into some funny state where I'm not reacting to these. Oh, the state's okay. I bet I can figure out... I'm converting the state when there's a mistake in the call thing. What is that? That's not in the call thing. That's in DevMan. What was I trying to do? I was trying to load. So like, load from chain capitalization. All right, load from chain. Yes, so load is what I'm looking for. Load, and one of these is adding, one of these is returning okay instead of the state coming back, which is bad. So what's the actual call path here? Load. Model text show. Load 2. Oh, handle troubling. I don't... Let's see, does load 3... Load from TX is the path that we actually took here. Does handle troubling in this... Aha! See, handle troubling returns okay. Not state. So any case of that right here... So there is no match on those like button types later because... Okay, that should actually fix the... What do I have wrong? Select number for state 609. Oh, I need a comma. Haha. That's not what I meant to do. That was my bad. All right. Mm-hmm. Okay, so these are all going through check TX. This would never make sense anyway. Even if we got that far, we just crash. Those types don't make any sense. Have a layout that shows the unsigned, the signed, unsigned transaction data, the signed transaction data. Any relevant messages. Oh, the transaction hash, that's important. Any relevant messages in the output. Well, the output would be the relevant messages, though. And you have three cases. You have success, return value. You have a successfully failed return value, and you have a failure, like to even submit it. When I say successfully failed, I mean you submit a transaction to a blockchain, and the receiving node can do some preliminary checks to see if it's even a valid transaction or not. Like whether or not it should be a burden to the whole chain to process this or not. And that obviously isn't, then you should reject it. So a rejected message is just an outright failure. That's what we're getting right now with the invalid transaction. We may kind of be getting that with the over gas limit thing. I don't know. Let's see. And then you have a validly submitted transaction that needs to go into the blockchain record. That transaction should be recorded, but the outcome of processing the transaction failed for whatever reason. It's like it legitimately was accepted as a real transaction, and then the summer contract, nope, and aborted. Those have to be tracked. So you have failed, successfully, you have like a rejected thing, a failure, and a success. Those three possibilities. They should all be accounted for a certain way. What I'm doodling with right here, transaction data, the textual info about this versus the widget. So there's like, I have the data, I have the binary data, and then there's showing it to the user, and it's kind of two different things. Like internal state versus shown state. And I tend not to treat what's in a display widget as data that I should read from the widget. I should push stuff into the widget to show people, and that's it. If I'm getting widgets are one way, basically. You should read from a widget or write to a widget, but you shouldn't read and write from the same widget. If you can avoid it. I mean, unless you're initializing it. It gets a little fuzzy when you do like rich text editing or whatever. My point is that the internal program state shouldn't be stored in a graphical widget. Not because that's fundamentally wrong. It's that later on when I decide that I want to take that widget away and that I need to access that program state, that widget might be gone. And there went that was this place I was storing it. It's kind of silly. So let's think of this in terms of oh, look, we have TX data, hash, and info. These are all just all over the place here. In practice, these are all text fields, which isn't right now. They're all widget things. I'll make a new type, which is going to be That implies the existence of a thing. Right. Okay. Jackson 3. 난가름이다. 뭐잖아. 케이스. But like 31. Yeah. Okay. Okay. Could never be. Okay. Yeah. Even better. it every time? Yeah, I can. Check the time. Not actually defined in WXRL. But it's not. Okay. That's cool. That's what I actually want. Okay. Get object type. Okay. That's kind of what I want. Oh, nope. That's the right spot. Yeah. Be nice if these interface functions are the same, but they're not. Okay. Mm. Mm-hmm. Out. How do I do the out data? Mm. Special case for singleton records since they're erased during compilation. So you get back a singleton record potentially. Hmm. Make up a special syntax for anonymous variant terms. Okay. Why are we doing a non-local return here? What's this typed as? Oh, nothing is typed. Nothing is typed at all. We have error here, but then we have a random airline exit in the middle of some of these too. We need to pick away and stick to it. Unless that's just supposed to be impossible. Fate to IO list. Where is this at? Not you. Ah. I'm asking the author what his thinking was behind that. It might have just been I was tired and I don't want to wrap the call sites. That happens. Okay. Oh, poop. It's already 1:30. I have to get going here in about 20 minutes. So I'm going to cut this short here. And I will be back later on to finish delving into the depths of what's happening in this new version of Hakuzaru, as well as how it's working with the wallet and where Gajudesk is barfing on these bad transaction submissions. We'll get it sorted out probably sometime today, and then have contract calls working. Yay! But I still have ugly contract call reporting. That's the other but that's not that big of a deal. It's just deciding how I want to show these return types and junk like that. So anyway, I'll need to get with the Jarvis who wrote this this HC Sophia thing. Ask him what's the best way to call this to get, like, the goal here is we're going to get the big chunky blobs from the contract call return. Send a contract call, it'll have a return back, and it's going to be like CT underscore blah, a bunch of just garbage. Doesn't mean anything to us. But that encoded garbage is going to have meaningful terms like, tuples or lists or string. Very often there'll be a string that says, like, a reason or return value or something. And we need to get at those and decode them and translate them to something that's useful for people to see, and print them as Sophia literals, which you can see some of that's what this does, is like pretty prints Sophia stuff, terms as Sophia literals. But there's a conversion step from that CT underscore blah, like base 64 blob, to fate terms. So that's one decoding step. And the next step is to take the fate terms and turn them into Sophia literals. So there's a multi-stage process, and I need to make sure I'm calling it the correct way. So I will talk with the author on that, and we'll see what we're up to tomorrow. But we're making progress, but it's a little slow until I come to terms with some of the new stuff here. But anyway, I'll be doing this